for your chance to present my research. Actually, I am a independent researcher. I am working for implementing different projects in different different social research. So here is my work is sentiment analysis. Sentiment analysis using various machine learning model and technique. This is one of the promising and usable thing in the world, mostly in e-commerce sector. Firstly, we can say sentimental analysis definition. Actually, sentimental analysis is the sentimental is also known as opinion mining. It is a subsector of natural language process. Actually, where a sentiment analysis is working for text in a text in any text. Any text focus on in a negative, positive, or in a neutral thing. This text from this text, sentiment analysis can give the quantitative information, negative, positive, or neutral information. This is the sentiment analysis main theme. In my research, I am using 3 different models with 3 different technique. First model, logistic model with vector count, TF-IDF word and n-gram. TF-IDF 1 n-gram. Second model, Bayesian Nebes theorem with vector count, TF-IDF n-gram. And third model, random forest with a vector count, TF-IDF word and n-gram. Using 3 different models in my research for 3 different technique. Working flow. For this research, we require data. We are collecting data from the web. That is real-time data from customer review. They are giving their feedback in the web. This is actually this data come from Amazon.com. This data collecting by structural language processing, but we're using API. For API using, we're connecting API to our to the web from the web. We can that web scraping. That is another web scraping, collecting data by web scraping, and then text process. After the text process, we are from the text you can extract feature from the text. From in the future we can apply 3 different model: vector count, TF-IDF word, TF-IDF n-gram. From the processing, after the processing, their supervised learning are process. Supervised learning from the retrieval give a result, classification result. This is the workflow, whatever I'm working in it. First, we need gathering data. Actually, data come from web scraping. I am using a Amazon product review. From the Amazon product review, we can collect. Actually, I am collect only three feature. One is the rating. Another is the title, and another is the content bar or their comments. In 3 feature, also collect 100 comments. hundreds comment from this from one of the product. This product is smartphone. A smartphone. This smartphone name is OnePlus 9 Pro. 9 Pro. From this data, if you visualize the data, we can see the data rating 1 to 15. 1 is the lowest and 5 is the highest range. That is the 5 category for rating the customer rating this data. For their analysis show 34% of the customers give 1, and another is another 32% is give rate 5. That is the highest rated 32%. If say there is another average rating, there's 2.9 is the average rating of the product. This is a real time reflection of the product. If any product, also visualize this text. Actually, we are focusing on their comments, not their ratings. For comments, they say they are mostly they say phone. The word there is a maximum word is a phone. Phone. They are typing phone. There is 171, and another is a second one is a OnePlus. OnePlus is a 50, and third is a Pro. Another is a less than or less than. There is a there in these comments you can find this word. If this word in good review, that means good review is the only highest review is rating 5. There is a visualization of the for the use for the word like use camera, create phone. This is the main word in this in their comments. If also say the bad review, you are rating 1. Bad review, that means give a 1. We say word worst model absolute use is the when there is a use what is a bad review. There is a combination of that equal review. This is the phone camera update one. This is the visualization of the database in word in from word convert to in a graph. This is the visualization. Now this is our main work. We are working for text preparation. From the database, we are collecting 100 comments. From the 100 comments on text, we are pre-processing. For the pre-processing, we normalize the data. All data are makes a lowercase. Punctuation, where all comma separation are removed. Numbers, all numbers emotion are removed. Stop word. This all text are removed. Rear word also removed. Lemonization, remove all suffix word for our preposition. This is the process for preposition. For extract the feature from the preposition, we can convert unsupervised learning problem to the supervised learning problem by using polarity score. A greater than 0 to be positive, and a smaller or to be negative. This is the result in the right side. This is right side. There is now we can say the 42% is the positive, and 57 is the negative result from this database. Now we can classify their result. Feature extract by using 3 different models to enable mathematical operation to and machine learning modeling. We can use three technique. One is count vector. The second is term frequency inverse document frequency. Third is term frequency inverse document frequency n-gram. Three types of technique used in three model. In three model, first model is the logistic regression. Logistic regression is the X is our text, or X is our main input, and sentimental analysis is our output. So you are using Python for Python language. Logistic regression fit to the X and Y model in this model. And Bayesian based theory, yeah, also fit this our model in Bayesian 3 for Python model. And for Python model, X is our input and Y is our sentimental output. Also fit on our research in random forest model. Random forest model also fit our classification, our model. Random forest model classification fit. X is our input and Y is our output by sentimental level. Now we can say our result. We can say result logistic regression. There is a logistic regression. We can say our result is logistic regression of TF, IDF, N-gram is 72. Logistic regression for TF and I-gram is 72. And logistic regression for count vector is 77. Here is the 77 is the highest score for logistic regression. Is the right side is the graphical representation, of left side is the description. Graphical representation 72 is the highest for logistic regression. And lab-based theory, our model lab-based theory lab-based is the TF, IDF, N-gram is 74. TF N-gram word is 74, and count vector is 76. Here is the 76. Count vector is the highest result for this our model. And our third model, random forest. Random forest, the random forest is n-gram score is 77. Random forest, what's that 76, and vector count is 80. Here is our highest result is 80 for a vector score. Vector score. So here is the vector is our main. You can say all rather in together you can say there is a highest result in the vector count random forest, which is 80% of the 80% accuracy. So from this we can also cross check our ROC. Here is the ROC. There is a almost random forest is the ROC 1-1. Random forest is the three technique 1-1, and also logistic regression is some less, and net base is some less. So we can say random forest is the best method for this research in this ROC. Now we can find random forest is our random forest for vector count is our main highest result. Since we got the highest result from the random forest vector count, now continue this with this result with guard search CV. For guard search CV is mainly hyper optimization, including random forest. In this case, random forest model train on count vector feature, achieving the accuracy of 82%. That means there is before hypermeter optimization there is 80%. Now there is increase there result 82 from 82%. So 2% is the increase for hypermeter optimization. Hyperparameter optimization is one of the tools to increase their performance. From conclusion from this research, we can say random forest vector count model is a great way to centimeter analysis with minimum amount of workflow. The accuracy of is 82%, and the model accuracy is going to up, and so we can conclude this model is performance well. Performance well. Also we can, if we can further work on it, there should be a large data model. I mean, here using a small data model, only 100 for our future work. We can work in a large data model with the real time information from the Amazon or any kinds of any kinds of product what is available in our. Thank you.